What is the difference between biochar and charcoal? There is lots of confusion among people, and some people, by seeing the picture or a video, they are immediately commenting that is not biochar. It is not so easy in the field to distinguish between biochar and charcoal because both are carbonaceous materials, and before 2007, if people were calling any carbonaceous material that is formed under normal atmospheric conditions through pyrolysis, the general term that was used is charcoal. But after 2007, that is the trend that we could see, people started calling biochar, especially in the context of carbon sequestration, using charcoal. Whether it is biochar or charcoal, usually it is formed from say about 350 degrees to 800 degrees centigrade because this is the normal condition. Even in a cook stove, biomass cook stove, when we extract charcoal, in this range of temperatures it is formed. In pyrolysis, under very less oxygen conditions or almost all no oxygen, the biochar is produced. We have different technologies for the production, but the basic fundamental difference here is the purpose of utilization of this charcoal. There the definition of biochar comes. Mostly when we are using this for the purpose of long-term applications such as soil amendment or treating the sewage water or for creating certain construction materials. There it remains in the environment say from tens to hundreds of years. So this is the main value of biochar. We want this carbonaceous material or this carbon in the form of biochar to remain in the environment for a longer period. Therefore, we will have all the benefits of the presence of biochar in the environment for a long period. That's how the carbon sequestration is addressed. If we are burning it again, say in your barbecue or in your smelting or steel industry or in your cook stove, it means the life of this charcoal is very limited and it gets converted into ash. Therefore, here the carbon sequestration value is not much. This is very fundamental thing need to be understood. In the context of this carbon sequestration and present biochar methodologies, that is measurement, reporting and verification methods, we are also looking at the environmental and social impact assessments also. The biomass available in an area, if it is not being used for any other purpose locally, means if it is addressing already some issues locally or the livelihoods of communities or ecological services, that biomass we should not use. Only the excess or leftover biomass which is otherwise wasted, that biomass has the priority. Similarly, for the uh, species selection, the exotic species can be utilized which are exceeding in that area. Otherwise, the local indigenous species from the respective forest areas will be used. So these are some of the important considerations. Whereas traditionally the charcoal production, if you see the 19th, 20th century, it had been a very big industry. Even before the discovery of the fossil fuels and vast seams of the coal reserves, they were cutting the forests and converting into charcoal and had been using for every purpose in their life. So here these aspects are being considered as an important issue for issuing the carbon credits or even for the policies of the respective governments of any geography or country need to be respected regarding this the production technologies which are permissible or not, the pollution norms, even cutting of this wood, even transportation, safety, and many other things are there. So that's how the biochar is not a thing that one things can do as they want. One need to be in this framework. Even at artisanal production, earlier there was lots of freedom, but here we have some systems which need to be followed. During the production of biochar, we have two important things to deal with in general. That is volatile organic compounds or VOCs and polyaromatic hydrocarbons PAH. These two are released especially during the initial phase of carbonization at low temperatures, and when they are released into the atmosphere they can have some impact even for the people who are producing, or if they remain within the biochar can have impact on the user or in the environment. So what are these VOCs? VOCs include methane, ethylene, benzene, toluene and xylene. Polycyclic aromatic hydrocarbons. They are multicyclic aromatic rings. They are formed due to incomplete combustion of organic materials. Wood vinegar is formed due to tapping of these gases and condensing in the process of pyrolysis, where it may contain volatile organic compounds as well as traces of polycyclic aromatic hydrocarbons. What is the procedure for activating the biochar? There are various methods to activate. One could use mild acids such as citric acid, acetic acid, or oxalic acid. One could soak them in these three acids overnight, and the next day could be rinsed or cleaned with low TDS water to neutralize the pH. And some people are using the strong acids also such as nitric acid or phosphoric acid. It is their choice based on the application for which it was intended. I have collected the biochar that is just produced, say from the open pit method or the Kontiki method. And first, what I am doing is I am quenching this whole thing with water. So in the process, the ashes that are existing gets dissolved with water, and we have this biochar. Second level is again you can rinse it with low TDS water, clean it and air dry it. This is one method. If somebody has huge quantities of biochar and if they have kept it in the open, including the rain could leach all these ashes and everything, and in the top layer one could find the biochar. Overall, this process reduces the contamination of the charcoal with ash. This is very important because if you are applying the biochar for acidic soils, it's not a big issue. The ash will also add some value to the soils, and the increased pH can be adjusted with the acidic soil. That is not at all an issue. But if somebody is applying this biochar for alkaline soils, already the pH is say around 9 and above, and within biochar also it is above 8 and near to 9. So this alkalinity plus alkalinity is a problem. So that's why at least the minimum thing one should do. This technique I applied around 2006 when I was working on the alkaline soils. The simplest method, I washed with good enough water, flowing water, and then I use this biochar. That is one of the simplest and easiest method. So next what to do? After washing this, if you have some inoculating media, that could be organic or inorganic as per your choice. Some of the inoculants that are popularly used in India, they could be like Panchgavya, Jivamrut or neem based tracks, fish emulsions, compost tea, vermi wash, or including enzymes that are specially prepared. We have a choice of inoculants. Those who want to inoculate with the chemicals or inorganic liquids, in India they can apply the urea, liquefied urea, ammonium nitrate solution, potassium nitrate solution, super phosphate solution, and potassium chloride solution. After inoculation with liquid fertilizers, both organic and inorganic, as per their choice, that can be kept for about 1 day or 2 days, air dried, and then we need to charge it with the, say, we have a different range of materials which can be used for charging, say farmyard manure, vermicompost, or animal manure, say from poultry, small ruminants, and other livestock, even piggery. So that can be added to the biochar. This way, the biochar compost is prepared at the end. This way, biochar compost can be prepared, and as I designed, this is named as geochar, and this can be applied in the required proportions to the soil. One should not apply too much to get the optimum result. They have to undergo these field trials. What is required, how much is required for a particular area and the soil. So field trial is a must activity. If they apply less, then also the user will not be satisfied, because too less also is not helping them to economize the investment. So I would suggest not to dilute whatever investment they are doing. Rather, take only that much area where how much you could invest and bring up this biochar compost and apply. There you get the maximum result. Next year you can extend to the leftover areas. That way it is not a burden to the farmer, and at the same time they could see the ultimate results. This is very, very important. So farmer doesn't wait for one day, because their livelihood is one of the important aspects. So this I encourage, and that's how this my intense trainings are helping to understand, right from germination testing to germination level of seeds, nursery, even the plants that are cultivated in poly bags or pots. Then again area application, line application and point application of the horticultural crops. So all these designs are there. So this is very, very important aspect in the process of adopting the charcoal as biochar for application, for the sustainability of soils, agriculture, food security and climate change, water conservation and many other sustainable development goals.